Greetings from the Tech Cave, Fenris here, and today we are taking a look at the Super Famicom. Now, this is one of many Super Famicoms that I own, as I regularly import these whenever I find a junk lot at a decent price, or happen to find a unit that will help round out shipping from Japan. Now, as you can see with this unit in particular, it has definitely seen much better days. Now, I have seen plenty of restoration videos relating to the Super Famicom and even the Super Nintendo, but I personally feel that a lot of them don't really do a true full restoration of the system, most of them mainly focusing on cleaning and retrobrighting the unit, and while I will be doing that as well, that is only a piece of the entire picture. I don't see like a lot of work being done on like the main board, which I feel is just as important as cleaning the exterior. And while I do see them like, dust or give it like a light scrub, there's more that needs to be done to these systems, given the fact that these are aging out at this point. Like, this system was released in 1990, 1991, so it's decades old, so it needs a lot more work than just a little scrub and a little dust in. So, let's break this unit down and do a proper full restoration of the unit. And as well, I plan on also adding some additional fixes to the unit to really clean up the system more. So, without further delay, let's go. Oh yeah, that's quite dirty in there. Let's continue breaking it down. Okay, so now that we got the unit broken down, I want to focus my attention on the top shell before we focus on like the main circuit board. The reason why is because I want to break this top shell down even further so that way I can get the plastics of this console fully cleaned and ready for retrobrighting. Now, I'm not going to go over those aspects in this video, mainly because it's just about the same as like any other restoration video. You throw it in some hot soapy water, scrub it down, and then you put it in the UV box with like your choice of hydrogen peroxide cream or liquid. In this case, I'm going to be using 50% cream on these and leave it in for like a day or two. Now, I know there's a chance of streaking and whatnot, but I feel like I've gotten the technique down to where I can get this done with like minimal to no streaking. And as well, I don't have any of the hydrogen peroxide liquid on me at the moment. So for the time being, I just make do with what I got. Now, the reason why I want to focus on the top shell in particular is because there are a couple key things to note. For one, your LED indicator is right here and it's actually plastic. As soon as you remove this front badge, this is going to go flying. So it's best to keep this in a safe spot. As well, to remove this top cover, what you want to do is just simply push in all the clips, and then you just want to keep going around until you get most of them, and then you just want to keep going until eventually you get the clips in sunken in low enough to where you should be able to just pop it out. You want to be really careful when doing this because there is a chance that you can crack the shell if you're putting too much pressure, but if you go nice and slow and easy, you can remove this with very much little damage as possible. So we're just going to remove that, remove this, and I mentioned this. We're going to clean this separately, but keep it in a very safe spot. It is easy to lose this. And then of course we're going to remove this, come back over here, push these clips in, and we're just going to unscrew the latching mechanism. Also keep this in a safe spot. It's easy to lose this as well. And yeah, with that, we got all the shell parts broken down. So now we can bring this over to the sink to get it all cleaned up, and then I'll get it thrown in the retro box. Okay, so while we wait on the shell to finish with its retro brighting, we can now focus on the main board. Now the first thing that I'm going to do is unscrew the rest of the main board and give it like a quick brush down with a toothbrush to just kind of get rid of all the dust bunnies. Okay, so here's a little tip that I wanted to bring up before we move on to the next step. Now, whenever I have serviced like these cartridge slots, especially for like the Super Nintendo and the Nintendo 64, sometimes the Genesis, but it's usually those two systems, every now and then I would find that when looking into the cartridge slot, there's like some dust bunnies that are just kind of crammed in there. It happens from time to time, but that's also problematic because unfortunately those dust bunnies can cause a break in connection to where you're not going to get consistent reads even if you scrub the cartridge slot. So the way I go about fixing this is I take my X-Acto knife and I just wedge it in between, gently glide and pull up like so, and you might actually end up lifting some dust bunnies. I actually got something right there, and I just go over the whole cartridge slot. Now of course you also want to clean it with some isopropyl or contact cleaner preferably, but I would recommend just doing this just to make sure that there's no dust bunnies trapped, or there's not anything else that's kind of trapped in there. Sometimes you'll get like paper or something that's stuck in there, but most of the time it's just dust bunnies. But yeah, if you just do that real quick, you can ensure that there's nothing inside the cartridge slot. So, with that out of the way, let's move on. So now that we got the board completely brushed down, we can move on to the next step, which is recapping the system. Now, why are we recapping the system? Well, this unit, as well as many other units that I have restored, exhibits some serious video issues. Mainly, composite video is much darker than normal, and S-video is so thoroughly compromised that the sync pulses aren't able to lock on correctly, resulting in an unstable image. This is becoming more and more commonplace due to vented or aged out capacitors. As these systems get older, these electrolytics aren't going to be able to perform as well as they once did when the system was brand new. As a result, they tend to either dry out or vent out, neither of which are particularly good, and the latter of which can do some serious damage to the board if not addressed sooner. So, let's get to decapping and recapping the system. So the first step of recapping the system is going to be preparation work. So what kind of preparation work do we need to do? Well, we first need to mask off all the plastic bits on the board, so that way when we go over it with our hot air rework station for the surface mount components, we don't end up accidentally melting something. So the points of focus that I'm going to be paying attention to are the reset switch, the cartridge slot, the sound slot, and the AV multi-out here. So let me just get my Kapton tape out, tape those up, and we can begin. Okay, so I got the points of interest all taped up and ready to go. Now, you may notice that I didn't tape the entirety of those connectors, and this is mainly because you only need enough tape to block off the area in which heat is going to come close to these connectors, and you also want to make sure they are as close to the PCB as humanly possible. Now, if you feel much safer doing so, you can tape up the entirety of the areas to make sure that they're safe, but generally speaking, that's all you really need. Now, one other thing that I'm going to be doing, and this doesn't really have anything to do with the recap process, but it involves a later process in the video, but I'm going to be removing the 7805 as well as the 1.5 amp pico fuse. Now, the reason why I'm doing so is going to come into relevance later, but since I'm going to be removing the old 1000 microfarad capacitor here, I might as well go over the 7805 and the pico fuse here as well. So let's get to it. Okay, so now that we got all those through-hole components removed as well as the fuse, let's get to decapping the rest of the board. Sorry about that. It looks like the camera died on me in the middle of filming the last step of the decapping process, which is spraying the whole board with 91% isopropyl alcohol and scrubbing it down with a toothbrush, and then rinsing and repeating until eventually I got most, if not all, the flux off. It was a little tricky because it was a mix of the factory flux as well as my own NC191 no clean flux. Yeah, I know the irony there. But before we move on to the next step, I want to point out something. So when removing all the capacitors, you might end up seeing that either the pads or even some vias are a little bit dull or corroded, and that's mainly just due to the fact that those capacitors may have already vented and already started eating away at the board. Now, the via in particular that I noticed was this one right here. You can see it's a lot darker than the rest of the vias. This is the via that goes up to R42, and it connects to these pads 59 and 60. And it's not apparent on the camera, but from my eyes, there is a bit of dullness around the edges. But I was able to confirm that we are getting continuity with these points. And to prove it, here's my multimeter. Consistent connection. And now we're just going to turn the board over. And I'm going to probe R42, which is where the via that connects to those two pads go to. I'm going to turn it to the side. R42 on one end, and consistent connection. Consistent connection. So we did confirm that those two pads are fine, but in the event that you feel more comfortable to make sure that those pads are as clean as possible, what you can do is spray a little bit of isopropyl alcohol on those pads and go over it with a microfiber pen. So just, oops. Just start going at it. You don't need to go like super crazy. And you also want to be mindful of the solder masking around the edges. You don't want to end up accidentally exposing that. But if it gives you peace of mind, and in some cases I would recommend just doing this anyways if the pads are like super eaten up, like I've seen with like a lot of Turbo Duos and Game Gear boards. But you can see that actually made a bit of a difference. And then of course you want to make sure you I'm kind of running out of isopropyl here, but spray the board and just kind of wipe it down. Alright, so now that everything is all prepped and ready to go, let's talk recapping. So when purchasing a cap kit from where I go, Console 5 specifically, you might see two options for Super Nintendo or Super Famicom, and that's leaded or SMD. If you want a more factory look, go with SMD because they will provide all the SMD capacitors as well as the appropriate through holes. Leaded capacitors are all through hole capacitors. And while technically the SMD capacitors do provide a more factory look, and I can install those just fine, I feel that the leaded capacitors are a bit easier to install. So let me show you how to do that. Okay, so I forgot to turn on the camera when I installed C62, so we're just going to look over here at C61. So how I go about installing a through-hole capacitor onto the surface mount pads is actually pretty simple. The first thing you want to pay attention to is the orientation in which you should install the capacitor. So the flat side here is going to be your negative spot, and the angled side here is going to be your positive spot. And when you look at a through-hole capacitor, your stripe side is negative and your non-stripe side is positive. So, in preparation of getting it onto the board, the first thing you want to do is bend both legs down and make sure that they are horizontally aligned. Like, you don't want them to be like super crooked. You just want to make sure that they're aligned as good as you possibly can. Then you come in with your side snips. Camera doesn't want to focus. Come in with your side snips, and you want to snip off as much as you can, but not all of it. You just need enough to where you can get it with your soldering iron. Something like that should just be fine. So now, all we need to do is add a little bit of solder to one of these pads. In fact, let me get my flux. We're gonna do the positive terminal. That'll do just fine. And then, just gonna turn the board on the side, it makes it easier to work. We're going to carefully introduce the through-hole capacitor into the surface mount landing. So, tack the surface mount pad. And we're just gonna carefully try not to burn our fingers. I'd recommend using tweezers, but if you do it just right, it should go in just fine. Looks like it's a little bit crooked. Doesn't have to be super perfect, but just good enough. So now that we got one side tacked in, we can come in with our flux. And tacked in the other side. Camera can focus. There we go. That looks like a pretty clean install to me. So let's do the rest of the capacitors. So now that I have all the capacitors installed on the main board, there's a couple things that I want to note. One, when doing a recap, I would highly advise that you either take notes of what capacitor goes where on the board, or checking on Console 5's website to see if they have a capacitor map. So that way you don't get lost in terms of like what capacitor goes where. As well, since we are working on an SHVC CPU 01, you may notice it comes with some extra capacitors. This is a 470 microfarad 6.3 volt capacitor, and these are 47 microfarad 10 volt capacitors. So these two capacitors actually go with the sound module, which we'll get to in a moment. And this capacitor is actually important to the next step of the restoration process, which we'll be getting to right now. So now that the system has been fully recapped and I still got some time on the clock for that shell, let's turn our attention to the extra stuff that we're going to be doing to this unit. So first order of business will be the VCC rail fixes. Now, one of the biggest problems with these systems is some noticeable video noise that appears to be caused by unclean power going through the system. Nintendo was being super cheap with manufacturing these systems and really skimmed out on both the power cleaning and one other thing that we'll be focusing on later. So how can we fix this? Well, let me show you. So the first order of business is installing a brand new fuse. And the reason why I'm doing this is because the original Pico fuses on the Super Nintendo are notorious for popping. So it's better to just install a brand new fuse. And while the new fuse can still pop, you know, it's a little less likely than a fuse that's like entering 30 plus years old. So to install it, what I usually do is I lay it down to kind of get a rough measurement, and I just clip the excess. Alright. And next, I'm gonna flux up these pads. Come in with our tweezers. And we're just gonna solder it in. Alright, let that cool down. And we're going to measure it just to make sure we didn't accidentally pop it in the middle of soldering. Yep, all good. The next step is going to be involving the shielding here, or more specifically, the part we're going to attach to the shielding. So you remember we had gotten rid of the original 7805, and the reason why is because as part of the VCC rail fix, we're going to be installing the 78S05. This is a 2 amp variant of the original 7805, and these run a little cooler than the original, not by much, but the important thing is these actually do help clean up the video signals significantly. So to install the 78S05, the first thing we should do, and I feel that we should be doing this anyways with even the original 7805, is we're going to take a little bit of thermal grease, plop just a little bead right there, and then we're just going to pop this guy right there, make sure the screw hole's aligned, and we're just going to bolt it into place. Oops. Oh yeah, also make sure that you're using the correct screw. You would know that you're using the correct locking screw if it has a circle ring on it instead of a spiked ring on it, like you would for bolting the RF shielding down to the main board. Tighten that up. And ready for install. So now that we got the 78SO5 installed, our next step is going to be removing C81 here. So we're going to be removing and replacing C81 with one of these. This is a 22 microfarad 10 volt 20% 0805 X5R ceramic capacitor, and this is for getting rid of the vertical bar that's prevalent on a lot of these Super Nintendos or Super Famicoms. So to remove the C81 capacitor, it's simple really. Put a little bit of flux, go in with your soldering iron, whoop, gone and gone. And installing it is just as simple. Just gonna peel this off. Plop it into place. And introduce our soldering iron, tack both sides, and just gently guide it in. And then we're just going to add a little bit of flux on both sides again. And we're just going to flow some fresh solder. And there we go. C81's been swapped out, and we can move on to the next step. And that next step is going to be finally installing that 470 microfarad capacitor that we got. So this is the reason why it's included with the kit. So we're going to be installing it on the voltage regulator pins here. So we need to attach the capacitor to the ground and output pads. So ground should be attached to the negative side of the capacitor, and output should be attached to the positive side. So the way I go about prepping this is I first fold the capacitor legs down like this, and then don't clip them, just use your snips to bend them up, like so. Actually, there we go. Just bend them up a little more. And we're just going to make sure that we can line them up. And much like with the fuse, we just clip the excess. We're going to add a little bit of flux this time to the capacitor leg. Tack one side in. That didn't work out, so let me remove that. Try again. Make sure we also don't bridge anything. A little better. Come in. Flow a little solder on the ground. And let's give a little more to that positive side. See if we can get it on camera. And a little more solder than I would like on the ground, so see if I can clean that up a bit. Well, it's about as good as I'm gonna get it. So yeah, that's how you install the 470 microfarad capacitor. Okay, so for the last step involving the VCC fix, we're gonna be focusing on this area right here. And the reason why is because we're gonna be installing these in it. Now, this is a little baggie that contains 100 microfarad 10 volt low ESR electrolytic capacitors, as well as a strip of 10 microfarad X7R 0805 SMD capacitors. And the reason why these are important is because we're going to be installing it in C90, C91, C92, C93, C94, and C95. These are the ceramic capacitors that coordinate with the main chipset here. Now, the point of these capacitors is that they're supposed to help filter out any sort of VCC noise. Unfortunately, they don't do a very good job at it, so that's why we're going to be installing these to them. The electrolytic capacitors in particular are going to be cleaning up the VCC rails around these chipsets to ensure that they get clean power. Now, the 10 microfarad capacitors are optional. These are only necessary if you find that even before all this, that your picture has jail bars in them. It's not very common with Super Nintendos, but some do have it while others don't. I just like adding them anyway as like an extra safety precaution. So, let's get to installing. So the first order of business is going to be stacking the 10 microfarad capacitors on C90, C91, C92, C93, C94, and C95. We are not replacing these like we did with C81. We are just simply stacking the capacitors on top of them. So let's get some flux on the board and we can get going. So now that I got all of these ceramics out of the way, we can then move our attention to the electrolytics. Now, as you may notice, there are no positive or negative markers along C90 to C95. And that's important because, remember, these electrolytics are polarized, so they need to go in a very specific way. So the way that we're going to solve this is that I drew up the position and location of each capacitor on a little sticky note here, and we're going to be poking around to figure out what signals go where. So the way I like to do it is I mainly check for which pin is ground. So what I'll do is I'll take my multimeter, probe one end to the shielding along the sides here, and poke the other end to each of the pads. So as we can see, the bottom of C90 here is ground. And just to verify that the top is VCC, we're going to take that same probe the top pad, and we're going to probe the output of the voltage regulator. So the top pad is VCC. And also, just to make sure there's no short. So we now know that the bottom pad here is negative, and the top pad is positive. So I'm just going to go around probing each of these points, and we'll move on to the next step, which is installing these capacitors. So I have all the necessary points marked here on my sticky note, and I would advise that if you're working on an SH3C CPU01, just to pause this video and to take a screenshot, that way you can also follow along. But with all of that marked up, let me show you how I go about installing these electrolytics. So it's actually very similar to the 470 microfarad 6.3 volt capacitor that we installed in the voltage regulator. We just take our capacitor here, in this case let's focus on C90. The bottom pad is negative and the top pad's positive. So negative, positive. I'm just gonna fold the legs down here. Camera doesn't want to focus. Then we're going to take our side snips. We're not going to clip. We're just going to use it to kind of grip on as we bend it up like so. And then we're going to just kind of dry fit it right there. That way we know how much we're taking off in terms of the legs. Space them out just a little bit, like so. And of course we're just going to tack it into the C90 here. So remember, negative, negative, positive, positive. That's one. That's two. So we got the first capacitor installed here. I might actually fix that up real quick. There we go. So we have the capacitor mounted onto C90, and we basically just have to repeat with C91, 92, 93, 94, and 95. One other thing I should note is make sure you pay attention to the orientation of your capacitors. I personally like to mount them in such a way that they go inward rather than outward. It should be fine either way, at least except for C90, because you know you have the shielding here and it might touch the bottom shielding as well. I just prefer to have everything kind of inward. So without further delay, I'm going to install the rest of the capacitors. Okay, so with that, we have all the electrolytic capacitors installed, and that concludes the VCC rail fix. Now, before we move on to the final steps of the restoration process, there's something I actually want to do real quick, and that is checking continuity to make sure we don't have any dead shorts. So I have one probe set to ground, and I'm just going to be poking the VCC rails of each capacitor. And what we're checking for is making sure, yep, we do not. So we do not have any dead shorts to ground. And just to show that I am on continuity mode, there you go. So now that we verified that's good, one other thing that I'm going to be doing before moving on to the final step is I'm going to check on the shell that I currently have in the RetroBrite box, because while to you guys this was a few minutes later, to me this is the next night. So I'm gonna go check on the shell really quick, make sure everything is good, and then we're going to come back to focus on one last thing before we can say that the hardware is just completely done. Alright, the shell does need to spend some more time in the box, so while we wait, we might as well go ahead and address the last issue that Nintendo left us, and that issue can be found in the sound module. So what exactly is that issue? Well, let me show you. So the first thing we're going to do is get this thing open. I'm just going to take a screwdriver here, loosen each corner. Alright, got the bottom exposed, now we have to get the top exposed. The top portion is going to be a little bit trickier. Want to be careful, because you can accidentally cut your finger. So now we got one side lifted up. Let's see if we can. Once you get one corner up, the rest just kind of pops up. There we go. Got it open. So now that we got the sound section open, we can focus on a couple issues. The first issue is these two capacitors here. They just need to be changed out, no big deal. But the bigger issue is this chip right here. This is the D6376. This is a 2-channel 16-bit DAC manufactured by NEC. Now, if you look at the data sheet for this chip, pins 9 and 10 are left and right VREF signals, and these pins are supposed to have their own 47 microfarad capacitors attached to them as per the application circuit example. Now, unfortunately, Nintendo decided to squeeze a couple extra pennies by feeding both VREF signals through a single 47 microfarad capacitor. This violation of the spec results in an audio imbalance where one channel may overpower the other. To what extent varies between system to system. Now, this problem mainly affects the SHVC CPU01 as well as any of the SNS CPU GPM boards. The SNS CPU RGB boards and onwards appear to have rectified this issue with a revised audio circuit, but needless to say, this is an error that needs to be corrected. So, here's how we're going to go about doing it. So the first thing I'm going to do is remove the two capacitors as well as the crystal that's in the sound module. We're going to be replacing the two capacitors, and we just need the crystal out of the way so that way we don't accidentally damage it with our hot air rework station. So now that we got all the through-hole components removed, we can now focus on removing the D6376 here. So simply put, we're just going to apply some flux. And just to make it a little easier on us, we're also going to just flow some fresh solder on it. This is that way we can lower the melting temperature, as well as knock off some any oxidation. And now we're going to go over it with a hot air rework station. So now that we got the D6376 removed, we can then move on to the fix. And the fix is actually really simple. We just need to disconnect pins 9 and 10 here with a craft knife, because the only thing that connects these two is a single trace. So once we disconnect them, pin 10 will be left floating, and from there we can then attach our own 47 microfarad capacitor to it. So you want to be very careful when it comes to severing the two traces. If you slip, you do run the risk of cutting any other traces, and that's going to be no good. So I'm just going to go straight to cutting the trace, and we'll move on. Okay, so it looks like I have successfully cut the trace that links pins 9 and 10 together, And just to verify, we're going to tap pins 9 and 10. And we can confirm no continuity. So, yeah, that's all that really needs to be done. Now all we need to do is install the D6376 back to the board and attach our 47 microfarad capacitor. So now that we got the D6376 installed, we can now install our 47 microfarad capacitor. So all you need to do to prep the capacitor is bend the negative lead along the side here, as well as bend the positive lead downward. The reason why is because we're going to be laying it on top of the D6376 and then connecting it directly to pin 10. So once you do all that, all we're going to do is just put a little drop of flux on pin 10, come in with the capacitor. The reason why I have the board like this is so that way I can see better. Make sure that the capacitor is laying down close to the board. Flow, wait for it to dry, let go. Give it a little wiggle test to make sure that it's solid. It is. And now we're just going to locate our ground. Now, right here on the side of C8 is actually a ground pin. And to verify, we're just going to probe with our multimeter. Yep, that's ground. So, all we need to do at this point is we're going to carefully bend that capacitor leg over to C8. You want to be very careful because you can accidentally snap off the capacitor, which that's going to be no bueno. And that looks good. No, it's still floating a little bit. So once you got your leg in position, now we could just flow some fresh solder onto it. So, drop a flux. Alright, we got the capacitor installed. So now we just need to install our new caps as well as reinstall the crystal here. Okay, with that, the sound section, as well as just the hardware in general, is all finished. So we have our 2 new capacitors installed, as well as the 47 microfarad capacitor that is installed into pin 10. Everything is still solid, so all we gotta do is just close it up, which that's gonna be really simple. Just clip it on, and if you did everything just right, the capacitor should clear the shielding. So we're just gonna come in here, the other shielding. There we go, all clipped in. So now all that's left is testing the hardware. Okay, so I have everything hooked up so I can test it. So I have my custom composite video adapter for the Super Nintendo, my power supply hooked up, and I have the RetroTink 5X, and as you can see from the input, we are on composite. So we're just gonna plug in our burn-in test cart and make sure it works. So come in here, we do get a light, and we do get a screen, and the timer is ticking, so that's good. So let's make sure, yep, controller still works. Let's hit the burn-in test and make sure that it runs just fine. Okay, so it ran through the burn-in test just fine, so we're just gonna power it down. And yeah, it looks like the system does still work. But just to make sure, let's pop in a game to see if it will run. So, got my copy of Kamen Rider here. And that looks to be running. So yeah, looks like we do have a working system. So let's also test S-Video, because as I've also shown in the examples, S-Video was also really unstable, and it's good practice to just test all video modes. So let's move on to S-Video. Okay, so I have my S-Video cable hooked up, and as you can see, we are on S-Video mode. So we're going to be plugging in Star Fox 2. And the reason why is because we also need to test the expansion pins on this cartridge slot. So just fire it up. And we do get a stable image. As well, the expansion pins do work because now we're playing Star Fox 2. But enough of that. Last but certainly not least, we're going to be testing RGB SCART. Alright, so I have my RGB SCART cable plugged in. This is an RGB C-Sync cable, by the way. And just to verify, we are on SCART RGB. And just for fun, let's plug in and let's do Spawn. And looks like we got RGB. And it's in full color too. So that's great. We have a fully working Super Famicom. Oh, and by the way, this is a heavily underrated game. I highly recommend playing it. But enough of that for now. But yeah, it looks like this system is fully working. So now, once the shell is all done with its retrobrighting process, I'll get it scrubbed down and we can put it back together. And with that, this Super Famicom is finished. Now, obviously it doesn't look factory fresh, but it certainly looks a lot better than it did when we started. As well, we have both the VCC and stereo fixes applied to this system for optimal performance. Now, I would like to thank my friends Ace9921, BorderlineOCD, and Mike G. Ace is the one who discovered the stereo issue found in these older SNES and Super Famicom models, as well as introduced me to the VCC rail fix. BorderlineOCD is the inspiration I took for some of the editing tricks that I used in this video and will continue to use moving forward. And finally, Mike is the person who mainly gave me the inspiration to do this video and was the one behind the beautiful RetroTink line of scalers in which I used the RT5X during the production of this video. All relevant links to their content are in the description below. Now, I do apologize for the hiatus I took between larger uploads. Life's been a little crazy for me after the first video, but I do hope to produce more content and have more to upload really soon. To stay up to date with me and everything that I do, feel free to like, comment, and subscribe. As well, follow me on all my socials in the link below. And as always, until the blue moon rises, I'll see you next time.